Welcome back. We're continuing on to our third section of 5.2. So today we're going to focus on using the conjugate root theorem. Okay, so the conjugate root theorem helps identify other zeros that rational polynomials have to have. Now before we do that, let's just go and review what we did in the last notes that leads into this. So write a polynomial function in standard form with 2, -2, and -5 as roots. So to have a root of -2, you need, or of +2, you need x minus 2. To get a root of positive or -2, you need x plus 2. And a -5, you need x plus 5. Now, when possible, it is intelligent to FOIL when you have two things of opposite signs, all right? Because when you have that, look at what happens. X squared, 2x minus 2x, cancels out, doesn't even matter. Then you have minus 4. All right, and then come down here, FOIL again to get x cubed plus 5x squared minus 4x minus 20. And there is your polynomial in standard form. All right, so again, just a review of what we did last time. So, what does the conjugate root theorem say? Well, the conjugate root theorem says that if you have a radical or an imaginary solution, they always come in pairs. Okay? So by pairs, what that means, for this first one, notice this root of square root of 2. So what the conjugate root theorem says is that negative square root of 2, in order for this to be a rational polynomial, that also has to be an additional root. That one actually has 3 roots because they always come in pairs. For this one, what it's saying is, again, this root right here has an additional root. It has a partner. They always come in pairs for the imaginary and radical roots. And for this one right here, this one, again, comes with its opposite partner, its conjugate partner. So that's all the conjugate root theorem says, is it identifies when we're going to have additional roots. Okay? Now, how does this help us? Well, we're going to need it when we have some imaginary or radical roots, because we know they're going to come in pairs. Let's take a look. Write a polynomial with rational coefficients in standard form given the following zeros. Hint. First, use the conjugate root theorem to identify the additional root you need. Right, so here the first thing is I can identify, I also need that additional root. Okay? In order to have rational coefficients, it needs that additional root. So, when I'm writing my zeros, now I'm making my factors. Remember, a factor of x is what just makes 0. Factor of x minus square root of 5 will give me that factor of square root of 5. And x plus square root of 5 will give me that negative square root of 5 root. So you still create your factors the same way. And again, whenever you have this, I remind you, FOIL intelligently. I get x squared. Now, x squared to 5 minus x squared to 5, those just cancel out. They're gone. Ignore those pieces. And then here, remember, a square root times itself. cancels out the square root piece, because that would become square root of 25. Well, the square root of 25 is just 5. So don't overcomplicate this. Don't overthink it. All right? And now for this one, I can just distribute that. So I get x cubed minus 5x. That's going to be my standard form polynomial. All right, what about this next one? Well, this next one needs an additional root of negative 2i. So that's where I always start. Identify if there's going to be an additional root. Now start making your factors. So x minus 1 will make the first one. X minus 2i and x plus 2i. Now again, FOIL intelligently. I'm going to FOIL these together first. So x times x gives me x squared. 2ix minus 2ix. Those middles are always going to cancel. You don't even have to worry about those middle terms. And then here, negative 2i times 2i. So I'm going to do a little side note on that one. So negative 2i times 2i. Remember, that would be negative 4i squared. However, remember those imaginary numbers. This I squared is negative 1. This whole thing is actually just a positive 4. So that one, you may have to do a little bit of side work to make sure you're keeping it straight. But again, ultimately, it comes together nicely in the end. It doesn't like conjugate work there. You just have to do a little side work sometimes. Now in this instance, we're going to end up having to FOIL again. So, x cubed plus 4x minus 1x squared minus 4. And it wants it in standard form. So I'm just going to rearrange it to look like that. And that'll give me that polynomial in standard form. All right, let's continue working. So here, I know I'm going to have this opposite as an additional root. So when I'm writing my polynomial, x plus 3, x plus square root of 7, x minus square root of 7. And again, FOIL intelligently, please. So I'm going to FOIL those first. X squared, 7 square root of x minus square root of 7x is going to cancel out. A radical times itself just cancels off the radical piece. So I'm going to end up ultimately being left with that. And now I simply FOIL again. X cubed minus 7x plus 3x squared minus 21. Write it in the proper order. And there you have it. You have your standard form polynomials. All right, and this last one. Now this last one, I will admit, takes quite a bit of work. All right, because you have 2 additional roots. You need that one to complement the square root of 2, and that one to complement the 3i. So sometimes you have to recognize when you're going to have 2 additional roots. All right, so Let's write this all out. So there are my 4 factors. A factor per solution. So I have a lot of foiling to do in this case. Now, lucky thing is each will FOIL with a nice pair. So let's FOIL these 2 together. X squared, square roots of 2x minus square roots of 2x. Again, just cancel out, you don't need them. A radical times itself cancels out. It just gives you that 2. Now let's talk about these. Again, let's FOIL it out. X squared plus 3xi minus 3xi. Those insides cancel, just like they always do. Now let's do a little side work for that last piece. So negative 3i gives you negative 9i squared. However, you know that that I squared is a negative 1. So ultimately, this becomes a positive 9. Okay? So, now that we understand that, now we just have to FOIL one more time, and then we'll have this. X squared times x squared, so x to the 4, plus 9x squared, minus 2x squared, minus 18. Here I actually have 2 like terms this time. So let's combine those together. And there is my polynomial in standard form. All right, so a lot of work for that last one. But again, it's fun to see how they fit together and how all these are created. So please take a moment here, write a quick summary for me, describing what we talked about, and then come back ready to do your practice work.